Hello friends, welcome to our YouTube channel. A complex electrical network can be easily analyzed if we consider it as an interconnection of several smaller and simpler modules. This not only helps to solve the problem easily but also reduces chances of error. Designers, when design a complex network, they design simple two-port modules and then interconnect them. This leads to error-free design and makes things simpler. It is also easier to shield the smaller units to reduce the parasitic capacitances to ground. A variety of interconnections are feasible. Today we shall discuss series parallel connection of two-port networks. Two-port networks can be interconnected in various ways. When we connect output port of one two-port network to the input port of another two-port network, we call it cascade connection. It is the simplest method and a very popular one. The overall transmission parameter matrix for cascade connected two-port networks is the matrix product of the transmission matrices of each individual two-port networks in cascade. The overall inverse transmission matrix for cascade connected two-port networks is the matrix product of the inverse transmission matrices of each individual two-port networks but in reverse order. When both input ports and output ports are connected in series, we call it series-series connection or simply series connection. The overall Z parameter matrix of series-series connected two-port networks is the sum of Z parameter matrices of each individual two-port network connected in series. When both input ports and output ports are connected in parallel, we call it parallel-parallel connection or simply parallel connection. The Y parameter matrix of parallel-parallel connected two-port network is the sum of Y parameter matrices of each individual two-port network connected in parallel fashion. When input ports are connected in series and output ports are connected in parallel, we call it a series parallel connection. The overall hybrid parameter matrix of series parallel connected two-port networks is the sum of hybrid parameter matrices of each individual two-port network connected in series parallel fashion. When input ports are connected in parallel, output ports are connected in series, we call it a parallel series connection. The overall inverse hybrid parameter matrix of parallel series connected two-port networks is the sum of inverse hybrid parameter matrices of each individual two-port network connected in parallel series fashion. Today we shall talk about series parallel connection. Now let us see how we can connect two two-port networks in series parallel connection. We have a two-port network A having hybrid parameter matrix HA. Its input and output port voltages are V1A and V2A respectively. We have a second two-port network B having hybrid parameter matrix HB. Its input and output port voltages are V1B and V2B respectively. Let's connect the input ports in series connection. Now the combined network is having input port voltage V1 and input port current I1. Let's assign the input port and output port currents of network A and network B. The input port current of network A is I1A and input port current of network B is I1B. The output port current of network A is I2A and the output port current of network B is I2B. So we can write for series connected input I1 equals to I1A equals to I1B. Applying Kirchhoff's voltage law, we can write V1 equals to V1A plus V1B. Now let's connect the output ports in parallel connection. Here the output port voltage V2 equals to V2A equals to V2B. Applying Kirchhoff's current law, we can write output port current I2 equals to I2A plus I2B. Now let us derive the overall hybrid parameter matrix of series parallel connected two-port networks. When we describe a two-port network using hybrid parameters, we express the input port voltage V1 and output port current I2 in terms of input port current I1 and output port voltage V2. The linear equations used may be written for network A as follows. V1A equals to H11A I1A plus H12A V2A and I2A equals to H21A I1A plus H22A V2A. For network B we can write V1B equals to H11B I1B plus H12B V2B and I2B equals to H21B I1B plus H22B V2B. For the combined network, we can write V1 equals to H11I1 plus H12V2 and I2 equals to H21I1 plus H22V2. As the input ports are connected in series, applying Kirchhoff's voltage law, we can write V1 equals to V1A plus V1B. Using the expressions of V1A and V1B, we get H11A plus H11B times I1 plus H12A plus H12B V2. Because the input ports are connected in series, we can write I1 equals to I1A equals to I1B, and as the output ports are connected in parallel, we get V2 equals to V2A equals to V2B. Applying Kirchhoff's current law at the output port, we can write I2 equals to I2A plus I2B. Using the expressions of I2A and I2B, we get H21A plus H21B times I1 plus H22A plus H22B times V2. By comparing the expressions of V1, we get H11 equals to H11A plus H11B and H12 equals to H12A plus H12B. Comparing the expressions of I2, we get H21 equals to H21A plus H21B and H22 equals to H22A plus H22B. So we can write matrix of H equals to matrix of HA plus matrix of HB. Hence we conclude that the overall hybrid parameter matrix of series parallel connected two-port networks is the sum of hybrid parameter matrices of individual two-port networks connected in series parallel fashion. This equation can be extended to include any number of two-port networks subject to the condition of interconnectivity being satisfied. Let's solve a numerical problem. It states that two identical sections shown in figure are connected in series parallel fashion. Find the overall hybrid parameters for the combined network. Let us find out the hybrid parameters for the network shown. The input and output port voltages be V1 and V2 and the loop currents are I1, I2 and I3 respectively. Applying Kirchhoff's voltage law to loop 1, we get V1 equals to 3I1 plus I3. The second equation we get V2 equals to I2 minus I3. From the middle loop we get 0 equals to I1 minus I2 plus 4I3. Hence, I3 equals to I2 minus I1 divided by 4. Using this expression in equation number 1, we get V1 equals to 11 by 4 I1 plus 1 by 4 I2. Using the expression of I3 in equation number 2, we get V2 equals to 1 by 4 I1 plus 3 by 4 I2. So the equations are V1 equals to 11 by 4 I1 plus 1 by 4 I2, V2 equals to 1 by 4 I1 plus 3 by 4 I2. Let us short circuit the output port, that is V2 equals to 0. So from equation number 2 we can write 0 equals to 1 by 4 I1 plus 3 by 4 I2. Hence we get H21 equals to I2 by I1, that is equal to minus 1 by 3. By using this expression in equation number 1, we get V1 equals to 11 by 4 I1 plus 1 by 4 into minus 1 by 3 I1. That is equal to 8 upon 3 I1. Hence we get H11 equals to V1 by I1, that is equal to 8 by 3 ohm. Now let us open circuit the input port. So I1 equals to 0. From equation number 1 we can write V1 equals to 1 by 4 I2. From equation number 2 we get V2 equals to 3 by 4 I2. Hence we get H12 equals to V1 by V2 equals to 1 by 3 and H22 equals to I2 by V2, that is equal to 4 by 3 more. Two identical sections are connected in series parallel fashion. So we can write matrix of HA equals to matrix of HB, that is equal to matrix of 8 by 3, 1 by 3, minus 1 by 3 plus 4 by 3. We have found that the overall hybrid parameter matrix of series parallel connected two-port networks is the sum of hybrid parameter matrices of each individual two-port network connected in series parallel fashion. Hence, Matrix of H equals to matrix of HA plus matrix of HB. So we can write matrix of 8 by 3, 1 by 3, minus 1 by 3, 4 by 3 plus matrix of 8 by 3, 1 by 3, minus 1 by 3, 4 by 3. That is equal to matrix of 16 by 3, 2 by 3, minus 2 by 3, 8 by 3. So today we have learnt that when input ports are connected in series and output ports are connected in parallel, we call it a series parallel connection. We have derived the expression for the overall hybrid parameter matrix of the combined network. We have found that the overall hybrid parameter matrix of series parallel connected two-port network is the sum of hybrid parameter matrices of each individual two-port network connected in series parallel fashion. We have solved a numerical problem to obtain overall hybrid parameter matrix of two-port networks connected in series parallel fashion. That's all I have for you today. I hope you have found this lecture useful. If you have any questions or suggestions, please drop it in the comment section below. If you have liked this video, give it a thumbs up and share it with your friends. Thank you.